already in package.
Yeah. Okay.
So we have two, because one is the sender, one is receiver, and then I will also show you how to connect here. But this is the first test we are going to do. So we are going to check if the software actually can acquire continuously the data, some data. So the first test, we just do it with the PC and with Arduino, and we have to verify that the software is actually can acquire continuously. So the software is made in MATLAB, is this one here, and I will save this one in the computer there. And what it does practically is connecting to the Arduino through the serial port, and you have to of course know which port it is, the correct one. I will show you later. Actually it's easy because this is the Arduino IDE, and let's say now I have two connected, but I need only one, so I disconnect this one. So now only this one is connected. So the Arduino IDE actually tell you where is the port, COM8. So you can open Arduino IDE and then you find out which port you have to use for the test one. So here we have to use COM8, for example. And the speed depend on the rate that this one communicate, the Arduino communicate, and is set in the program of the Arduino. In this case I set 7,600. We can also change it, but this one is the one that I found for the moment that is the best. Again, we can change it to see the effect of changing this rate. Then what it does is practically setting a few parameters of the software to create the correct plot, because the plot will be values that you get versus time. So to create the correct time axis, you need to know how often the data come from the Arduino to here. So every time you get a data, he assign to each data a time value. So you need to know what is the interval between the data, and the sampling frequency is 2,500 Hertz. And the period, this is the calcul of the period of the sampling frequency, which means that so the data is coming from here to here every 2,500 Hertz. Of course, this one has to be coherent with the program in the Arduino. So here there are some line of code which set the Arduino so that the frequency that is using is also 2.5 kilohertz. So 2,500. So it did have to be coherent also. And here you can specify how long you want to acquire the data, and the value here is in terms of seconds. So if I write do, it will be 2 seconds. And here you calculate how many samples will be in the entire figure, in the entire plot, by doing simply the period of the measurement, 2 seconds, divided by the sampling period. So I know how many points there will be. And here also practically what I decided in this software is that I will acquire 1,000 samples, after which I will refresh the plot. Because I cannot create a plot every time I acquire a byte, because otherwise it will take more time to actually plot it. And the time that this one takes to plot the data, a new one arrive, and so it will crash because more data arrive and I don't have time to plot it. So the easiest one is to wait that a certain amount will arrive, like say here with 1,000 for example, and after 1,000 I plot the data, so that my instruction that plot the data take a certain amount of time, let's say 2 microseconds, and no matter that new data will arrive, it doesn't matter because I have to wait 1,000 before to do another plotting again, so I have sufficient times to plot. And then this one is the something that I used to create the time axis, so it's not it just will be between 0 and this one is the number of bytes per uploading the data, which means that is this one here practically. So if I have 1,000 samples, so if I refresh the figure every 1,000 samples, so this time axis here will be between 0 and 1,000, but this is multiplied for the sampling frequency, which is so this one will be the axis for 1,000 samples. And this one is the number of time that I will refresh the plot, so at the time that I add more data. So if I have 2 seconds, I will add 1, 2, 3, 4, 5 until I reach 2 seconds. So this is the number of time that I refresh the data. And, And then there is the time per refresh. So in this case will be just the number of points. So 1000 times the period sample. Then I get what is the one period of for 1000. And here is just some MATLAB. Practically I create something called a structure which has different properties. It's like you create an object which has different characteristics. And the characteristics are actually this one in purple. So one characteristic of this structure is called data. One characteristic is called byte, count byte. So they are properties. For example, imagine a computer which has different properties like memory, then also graphic card or something like this. These are characteristics of the yeah. And each one of these is assigned one value, right? For example, the RAM is 1 gigabyte or yeah. So this one is the name of the property of my object, which represented the serial connection. And this one will be the initial value of that property. For example, this property called count byte is start from 1. Then I will update this one. And this one, for example, when I say count byte is a variable which is used as a counter. That will use, okay. And then I create other characteristic in this object. It's not variable. And the main program finish here. So practically this one set the serial communication with all of this property. And then this instruction finally tells that I have to execute a certain amount of instruction every time I get a byte. How many byte? This number here, which is 1000 that I said before. And every time I get 1000 byte, then I go to execute this function here. And this function here is in this script here, which this script is very easy. What does it do is create the correct time axis for the plot. It plot the data acquired. Oh, sorry, I forgot. This one is the one that read the data received. So then I create the axis, I plot the data, and that's mainly it. So, and this one is repeated every 1000 samples. Once you finish everything, so to acquire the 2 seconds that we said before, what I do is that I extract all the data in the plot. So I have a figure that MATLAB create. I extract all the data and I save it into variable called xarray and yarray. And then I practically save in a file which is called data.txt. So you can find all the data acquired in the whole figure in one file, data.txt. And then practically I turn off the serial connection because I don't need it anymore because it's finished. So it might be look complicated, but then as soon as you maybe take some time to read it, then you will understand it better. Okay, but so now what we do is we try to get the data from this. Of course, as I said, you need also an Arduino code. This Arduino code here specifically create number between 0 and 255, and each number come out every 2.5 kilohertz. So there are some setting to set a timer inside Arduino, which every 2.5 kilohertz go to create an interrupt. And during this interrupt, I practically update a variable which is called cont. So I do cont +1 and every time I then send out the variable cont, which is practically this number that I send out between 1 and 255. And the number has 8 bits, and it follows the protocol called UART, which means is an asynchronous protocol, and is used when you don't send the clock, because usually to understand the transmitter and the receiver you need also a clock, because you have to understand what is the speed of the data that is coming. This protocol does not need the clock, but you need to fix some rule which identify when the message start and when the message end. So this protocol called UART, and the UART use 1 bit for start and 1 bit for stop. So you always have 1 bit start and 1 bit stop, and and your data will be sent in between these 2 bits. So the total number of bits is 10, but the data bit is 8.
8, yeah.
So okay, so this one is I think already uploaded here, but we can upload it anyway. So we know that the Arduino board is Arduino Uno, but you can also find it here, Arduino Uno. Then the port com is 8. We select the port com 8, and then this should be Avris MKE. Yeah. Once select everything, we upload the program in the Arduino, which is relatively straightforward, I think. Should be. See here, done compiling and done uploading. So this is uploaded. Okay. This one is not necessary anymore. We can close it, and we can just live with this software here. We create one thing I didn't say, I think, in the code is that the Arduino will start to send the data only after we send the character A, because otherwise it will always send it, and yeah, so it's better to start the acquisition whenever we want, right? So this last instruction here practically test all the time what the Arduino receive, and when it receive A, the character A, then it start the timer for inside to send all the data. So in this code here, there is nothing that actually send the character A, so we have to write, I can also write it there, but at the moment I have to write it here. So my point is that we run the script, remember that we have to send A, so you see now I get the control again, and now I already did it before, so this one is the instruction that send the character A. The S represent the serial port variable. So if I do this, then I send the character A, and now I start acquiring data. And this one is of course after 2 seconds, and now we can. The only things I didn't implement is that we should send then a message to stop the Arduino, because now you can see there is a LED close to TX, which means that it's still sending. I don't have any function done for the moment, so I just disconnect it. But what we want to test in this test is just the software that acquire everything. And you can see now, for example, in one period of this is data between 0 and 255. After 255, then restart from 0. And this is a plot which is created by stem. So each one of these dots represent the data acquired. And here there is the x-axis. So this test here just say that what we have to verify is that every time we get all the number between 0 and 255. So ideally one should go through all the period and verify that we get all the data, but at least qualitatively you can see there is no dot here, there is no circle here in the x-axis, so I can immediately say that I don't see any particular issue. So
but can be automatically to count any losts on?
No. So that is something we have to do it by ourselves. But I can implement also definitely something like that. But let's just go through the last maybe period here. Yeah, so to be honest, I don't see anything. But of course, you can go through again and double check that there is no dot here. But this proves that the software is able to read all the sample correctly, and there is no sample missing, because if one was missing, then it would have been here, or it wouldn't reach 255. So this one proves that we are able to take all the sample that this one sent. Here it seems that maybe it's going down, but actually if you do the zoom, there is no sample here. So you can also, but we can write also a function, maybe it's easier and faster actually to control that everything.
Just like final total sum, sum of numbers,
But remember there are different type of error, like one of the sample can be 0, but then it still reached 255. Data corruption data. So the function that check the reliability should be written well. You have to consider all the type of error that can happen. But for the moment, visually, we can say that there is no error. We can also try to do this one just for test, for the sake of verify that it works, that we can change the time, for example. Let's do 10 seconds, for example, to make it a bit longer. So, okay, see, this is an error, and it say that practically doesn't find anything in the COM8. That's correct, because I disconnected here. So also the MATLAB will tell you what is the error. Once you connected, you also get this message here which say, okay, I saw there is an Arduino connected, so now we know that everything is fine. So now we can run again the script. Remember that this one will not send until we send the character A. So we have to select this instruction here to send the character A. The difference with the previous test is that now we select 10 seconds. Okay, I changed that one from 2 to 10. Start again, and now it should acquire in theory until 10 seconds. Yeah, and then we stop. We disconnect it just to not make. Because if we don't, then the data continues to write to MATLAB, and the buffer of MATLAB can become so huge and it can make crash MATLAB. So, but we have to find then maybe a little function. We can look maybe the last period. You see, I don't see any error again. At least visually, I don't think there is any issue. The software itself. And if you look about, for example, let's say from the first samples here, you can see the time axis is actually should be ideally set correctly. This is 400 microsecond because this is 10 to the minus 3. So, and if you do 1 divided by 2500, it's supposed to be 400 microsecond. Yeah, so the time axis is correct also. Okay, so this one proved that we can also prove 1 minute, just to say the sake of saying that this one can actually measure as much as time as we want. Because it's good to test it for different times. This one here, and this. We might need to wait a little bit, but it took a little bit of time to actually write the callback function in such a way that the time to plot is very fast. It has to be so fast, because if it takes a long time, then this one will plot a bit in delay. So this one is the most real time that I was able to get. Of course, it's a bit in delay, but for an amount I think negligible. So disconnect it here. Okay. And we should be still able, you see, to collect all the data between 0 and 255. We can check. And this one is again 255. Yeah. So it's I tested a few times, so I think the software worked quite well. The software itself should not introduce any error. That's my point. This will start from 0, so I think it's pretty okay. Now the issue is that so the test 1 is practically now completed. We send the character A and we get receive a character from 0 to 155 with this waveform here, which we verified. So we know that the software at least can acquire at least 4 minutes. You can do other tests to make it longer, maybe more minutes.